testing will give us to the learning of the knowledge that is, how are these response variables related to the inputs? And that's what we're really after. We're really after long-term knowledge about our processes. So you're going to hear other terms today like levels. A level is a unique value or choice for a factor, an X factor. For example, CPU type. The two levels might be an Itanium or a Xeon CPU. Okay, so there are two choices or two levels for CPU type that we would like to test. The levels are the number of settings or the number of alternatives or choices that we have for a particular variable. The operating system could be Windows or Linux. Everybody follow that? So you have levels or settings that we will test at. We will test these test parameters at different settings. That's what a level is called. A run is a shorthand word for an experimental test combination, because we are going to look at combining or taking different test combinations of these levels for each of these factors. Like we could test an Itanium CPU with a 2.5 gigahertz CPU speed, with a 1.5 gigabyte RAM, with a 50 gigabyte hard drive size, with a .NET virtual memory, with a Windows operating system. So that would be one combination, or what we call a run. So a run is an experimental combination. Now, a new term that you may not have heard of is a replication. Replication means doing something over again. Replicating means doing a test a second time, or maybe a third time. Now, why would we want to do that? Anytime you have potential variation that comes out in the output, that is, if you put a specific combination of the levels of the 6 factors shown here together, and you test them, and if you did it again, and the possible result, the number of home page loads per second, could be different the second time, that's called a stochastic process, or you have variation in your output. That's why we do replications, to see what kind of variation that we could experience in the output. Variation is the enemy of customer satisfaction. Okay? You all know that, right? When the customer does this and something happens, and then 2 days they do the same thing and something else happens, that's called variation. All right? And that's what replications do. They help us repeat the experiment. It's also, the number of replications is also known as the sample size. Okay? Sample size means the number of times we're replicating. Now, if you're testing a system, maybe it's a software system, maybe it's a simulator. In software simulation testing, if the simulator is a deterministic system, that means if you test the same combination inputs and you'll always get the same result, there's no need to replicate. Replicating would not do you any good because you're always going to get the same result. That's called a deterministic system. But I want you, when you leave here today, to understand that you will be dealing with not only deterministic systems in your lifetime, but stochastic systems as well, where the output is going to vary. And we've got to understand both scenarios. But sometimes, if you're dealing with a system where if you test the same combination over and over and over again and get the same result every time, that's a deterministic system, okay? But you need to know, even with deterministic systems, how to handle that, and that's what we're going to cover here. An effect is what we call the impact of a factor on Y. What impact, for example, would changing the operating system have on the number of home page loads per second? Would that have an impact? We say its impact is called the effect of an input on the performance measure of concern. And then an interaction effect. This is where DOE makes its money for you and its company, and your company, okay, or your organization. Interaction effects are really hard to come by in testing. What is an interaction effect? An interaction effect is when the effect of one factor depends on the level of another factor. Okay? Interaction effects are hard to get to. There are only certain types of designs, test designs, that will allow you to get to interaction effects. And that is not known in the test community in general. There are only certain types of designs that are going to allow you to evaluate interaction effects. Now, the best way I can explain an interaction effect is if you take medication for something, and you have one medication that controls this, and you have another medication that is, say it's controlling blood pressure, and you have another medication that's controlling diabetes, all right? Do those medications interact? They could interact and create some difficult side effects for the patient, all right? So let's see another interaction effect. If I can demonstrate this on this, you may not want to go that way. They have a session over there. Let's is covered up here. Maybe I will. Okay, I do this. This opens this up. This will scare them over there. But let's say I want to open this door. So the performance is measured is how far can I open that door? That's my output. That would be this guy over here, one of these guys. That is, how far can I open this door? Now let's say there's two factors that impact how far. One is how hard, how much pressure or pull that I put on the door. That's one factor. Another factor would be the position of this knob or this handle. Down or up. When this is up like this, I'm going to have to pull like the dickens to open this door. But when this is down, not much pressure at all. That's called an interaction effect between the two inputs. The input is how much pressure I put on the door and the position of the door handle. Get the idea here? So when the position of the door handle is down, it doesn't take very much pressure or pull strength to open the door. But when the position of the door handle is horizontal like it is right now, it takes a lot of pressure. That's called an interaction effect. And a fellow by the name of Tolstoy said, a long time ago, he said, the combination of events is beyond the comprehension of man. But this is what DOE buys us. DOE is going to allow us to look at interaction effects, which are very, very important. If you have a problem out there in the software arena or hardware or some combination, it's usually not due to one thing. It's usually due to multiple things, okay? And that's the really crux of testing, is to find those interaction effects. If you can find interaction effects in your testing, you will be so much further ahead, okay, in terms of knowledge about the process. So I want you to understand this word interaction. It's a very important word, and it's something we're going to look at today. So if you looked at these factors and their respective levels, if you tested everything, you had two choices for CPU type, two choices for speed, two RAM types. You have two choices for each of 6 items. You would have a total, if you were to do every possible combination, there would be 2 times 2 times 2 times 2, 1, 2, 3, 4, 2, 4, 5, 6. This is 2 to the 6th power. That is 64 test cases. That's what you would have to test if you were going to test every possible combination, right? Because you have 2 choices for each of those 6 variables or test parameters that we call. So when you're done with the test, when you're finished testing, what kind of knowledge did we gain? What did we learn from the test? That's what we're trying to determine. Which of these is the most important? Do you have interaction effects between CPU speed and CPU type, for example? Okay? Which are not important? Which ones don't we have to worry about? Which ones shouldn't we have to control in the operational field? Which combination of factors will maximize our performance? That is, increase the number of home page loads per second while decreasing cost. Okay? And we want to be able to do what is called multiple response optimization. That is, get the greatest number of homepage loads per second at the lowest cost, right? Because cost, typically, we want to reduce that. So how do you know for sure? Show me the data. The data will come from a specific test that allows us to evaluate these types of questions, all right? That is learning. If you can answer these types of questions when we're done testing, you will have learned or gained quite a bit of knowledge about the system under test. And that's what it's about. It's all